Hello friends, today we are here to start the lecture series of Mathematics 2 and our chapter is Vector Calculus. First of all, vector function of the single scalar variable. If in some interval, open interval AB or closed interval AB, for every value of scalar variable t, their corresponding value of r bar, then r bar called a vector function of the scalar variable t, which is denoted by r bar equal to f bar t. Okay. If ij carried three unit vectors along with the three mutual perpendicular fixed direction x, y and z, then r bar equal to f bar t can be decomposed as r bar equal to f bar t, f1t I caret, f2t j caret and f33 k caret, where I, j, k are directions. f12, f23 and f3 are scalar function of the t. The relation between the relation can also denoted by f bar equal to f1, f2 and f3. So we write f bar t as under root f1t whole square plus f2t whole square plus f3t whole square. Okay. Now vector field. A vector function f bar xyz is called vector field defined in the region R if it is associate of vector quantity with every point in the region R of the space. Is the gravitational force and velocity of the moving fluid. Then scalar field. A scalar function phi xyz is called scalar field in the region R if it is associate scalar quantity with the every point in the region R of the space, like density of body and potential due to gravity. Gradient. The vector differential operator delta, or we say that is a nebula, is denoted by from nebula formation and is defined as nebula I caret del by del x plus j caret del by del y plus k caret del by del z. The gradient of the scalar field is denoted by gradient of phi or nebula of phi is defined as gradient of phi, nebula phi. So we say that del phi by del x I caret, del phi by del y j caret and del phi by del z k caret, which is vector quantity. Next topic, divergence. Divergence of vector field is denoted by divergence of f bar or nebula of f bar and is defined as divergence of f equal to I del by del x I caret, j caret del by del y, k caret del by del z into f bar. What is f bar? F bar is a direction, f1 I caret, f2 j caret, f3 k caret. So we take del f1 by del x because I into I is 1, j into j is 1, k and k 1. So we say that it is del f1 by del x, del f2 by del y and del f3 by del z, which is a scalar quantity. Solenoidal vector field. A vector field f bar is said to be a solenoidal if divergence of f bar equal to 0 at all point of the function. And the property of the function is u equal to xyz, v equal to xyz with a two vector point. Phi be a scalar point of the function. So we say that nabla u plus v, it is a addition property, multiplication property and associative property which is satisfied with these two functions. Okay. Now it is a physical interpretation. The divergence of the vector field u at the given point may be regarded as a measure to how much the field diverges or emanates from the point. That means any point, it is vector field is how much to go into different direction. There is a divergence point. See, or they are coming from the point or they are going from the point. So this is a measurement of the how much field diverge or emanates from the point. Consider the vector function vxyz xi by j and zk caret. If we find the nabla v, I del by del x plus j del by del y plus k del by del z, xi plus yj zk caret. If we are multiplying this, we get 1 plus 1 plus 1 equal to 3, where v has a positive divergence at every point. That means we say that there is a positive direction divergence point. And similarly for minus xi, minus yj and minus zk caret, we say that it is negatively diverged at every point. Now we are taking example. A bar equal to x square zi caret minus 2y cube z square j caret plus xy square z k caret. Find nabla A bar at the point 1 minus 1, 1. First of all, we find nabla A bar. Formula is nabla del A1 by del x, del A2 by del y, del A3 by del z. What is our A1? A1 is x square z. A2 it is minus 2y cube z square. A3 is xy square z. Put the value of A1, A2 and A3 and differentiate with respect to x. We are differentiate this function with respect to x, we get 2xz. With respect to y, minus 6y square z square, and with respect to z it is xy square. And put the value of 1 minus 1 in this equation, we get minus 3. So we say that it is negative divergence at the every point.